Well, hello guys, here Mr. G with another video for the Cratens. This is going to be for paper to still, and this is about physical change mostly. This is question 3, done in one of the control tests at my center, and we're going to see the question. The question say, the unbalanced chemical equation 1 and the word equation 2 for two chemical reactions are shown below. And then you have two chemical reactions there. 3.1. Which one of reactions 1 or 2 is a decomposition reaction? And if we recall real fast here, decomposition is when you have a substance together, for instance AB, and that one is broken into A plus B. That is decomposition, guys. So in this case, which one is the one? It will be reaction 2. Quite simple. A synthesis reaction. And then remember, a synthesis reaction is when you have two compounds or two substances, for instance A and B, and then you form one AB. That is a synthesis, and in this case the reaction is reaction 1. Very simple. Okay, what does G in reaction 1 represent? And that is very simple. G represents gas. That is the state of matter. This one here represents the state in matter. Balance reaction 1. So let's balance reaction 1 real fast. And this one is quite simple. We're going to start with chlorine. Chlorine, you see in the left hand side, there is 2 chlorine, and in the right hand side there is only 1 chlorine. So to balance this one, you have to fix at the front. So this is a 2 at the front. Now we have 2 chlorine. You go to hydrogen, you have 2 hydrogen and 2 hydrogen. So the equation is balanced like that. So let's write it here at the bottom, already balanced. Cl2 plus, let's write the symbol of the gas, plus H2, also gas. It's going to give you 2 HCl, also gas. The only number we change is this one here. Remember, for the balancing equation, the number of atoms must be the same. Alright? So you need to know that the number of atoms of reactants must be equal to the number of atoms of the product. That is in order for you to be able to balance the equation. 3.4. Use the balance equation in question 3.3 to show that mass is conserved in a chemical reaction. We already did a video on this one, but this is important. If this one is not working, when you solve this question, if this one is not right, it means that the balancing was wrong. So we're going to use that equation to balance or to calculate or to prove or show that the mass was conserved. Okay. And for this question, you need the periodic table. What are you going to use, guys? You are going to use the mass. If you go to your periodic table, you can see that the mass of this one, at least I'm using the mass, is at the bottom. You can see here in this place here. So we're going to look for the mass of each substance. Now for this law of conservation of mass, remember that the mass of the reactant must be equal to the mass of the product. So all we have to do is to calculate the total mass of the reactants. Now we'll start with the reactants. What we have in the reactant, we have chlorine, Cl2, which you can see is at here, at this point here on the right of the periodic table. Here we go. And we need hydrogen. Those are the two elements involved in this chemical reaction there. There is hydrogen. Okay, so now we're going to go and we have, let's do it for reactant first. Reactants. Now in reactants we have a chlorine, but we have 2 chlorines. Be careful. So we have 2 chlorines. So it's going to be 2 times the mass for chlorine is 35,5. You can see it in the periodic table. Plus 2 hydrogens, and hydrogen is 1. So it's 2 times 1. And this answer is going to be 71 plus 2. The 4 is 73 grams per mole. Alright, so that is for the reactants. Now for the products, we have that is going to be 2. These 2, remember, affects everything behind. So it's 2, and then I'm going to open a big bracket there. Let's pick a page here so you can see it properly. 2 times. First we have 1 hydrogen, so it's 2 times 1 plus, and then is chlorine, which is 35,5. So when you solve this one, you have that these 2. Solve first the bracket, so it's 30 multiplied by 36. Let's use the brackets here. 36,5. And that is equal to 73 grams per mole. Guys, you can see that the total mass of the reactants, is equal to the mass of product. Right? So the law of conservation of mass is applied there. Quite simple. All you need to do is to use the periodic table and look for the mass. If this one is not the same, then the balancing was wrong. Next question, calculate the percentage composition of hydrogen chloride. Very good, because we didn't practice something like this up until now. Calculate the percentage composition of hydrogen chloride. So what are they asking you here is to calculate what is the percentage of hydrogen in hydrogen chloride and what is the percentage of chlorine in hydrogen chloride. And it's very simple, so nothing to worry about. The first thing we have to do, step 1, let's use the right here, step 1. So the first thing we're going to do is to calculate the molecular mass of the compound. Be careful, because in the previous question, this is not the molecular mass of the compound. That is the molecular mass of the compound with the 2 at the front when it's balanced. So the compound is HCl, and we have to calculate the molar mass for that one. So this one is going to be 1 for hydrogen plus 35,5 for chlorine. Using the periodic table, I'm going to write here mass for that one, and this is going to be equal to 36,5 grams per mole. Very simple. So now you are going to look for the molecular mass of each element. For instance, for hydrogen, molecular mass for hydrogen, we have it, this 1 grams per mole, no mole, grams per mole. That is for hydrogen. And for chlorine, we also have it. It's going to be 35,5 grams per mole. Guys, and the last step is calculate percentage. Calculate percentage for each of those 2 elements. So what percentage of hydrogen represent in the hydrogen chloride? It's very simple. So for hydrogen, what you are going to say now, what is the actual way I do this? I say 36,5 is the 100%. Hydrogen, which is 1, what percentage represent? It's a cross product, guys. Quite simple. All right. So when you do cross product here, you will get that X is equal to, or 36, let's do it properly, 5x is equal to 100 times 1. I'm not going to write the 1. So X is equal to 100 divided by 36,5. And this will give you that is equal to 2,74%. So this is the percentage of hydrogen in the compound. So out of the compound, 2,74% belong to hydrogen. And all we have to do is to repeat the same for chlorine. So what you are going to say for chlorine, the percentage for chlorine, you know that 36,5 is going to be 100%. Therefore 35,5, which is the mass of chlorine, how much will be in percentage? And once more, you do the cross product here. Very simple. When you do this cross product, you have that 36,5x is equal to 100 times 35,5. So you have that 36,5x is equal to 3,550. Then x, this is simple calculation, guys. I'm doing step by step, but I don't think there is a need, but it is fine. 50 divided by 36,5, and then this is going to give you 97,26%. So that is the percentage of chlorine in hydrogen chloride, guys. That is the answer here. And that is the end of this question 3.5. Now, question 3.6. Write down the chemical formula of the following: aluminium carbonate, aluminium oxide. So, very simple. We've done videos already on this one here. For aluminium carbonate, we're going to write the ions right here. Remember, aluminium will be Al3+. Carbonate is going to be CO3, and then there is a 2-, but remember the 2- is for everything. The 2- is for everything. So now these numbers will change places. This 3 is going to move the outside for everything on that side, and this 2 is going to move all the way here for the aluminium there. Okay, so what will you have then? You will have Al with the 2 that is coming from the CO3 bracket, because it's for everything, CO3 close bracket with the 3 that is coming from aluminium. Very simple. Aluminium oxide, same story. Aluminium is a 3+, Al3+, and then oxide is O2-. Once more, those numbers swap places, the 3 and the 2. 2 is going there, 3 is going there. So the final answer is going to be Al2O3. That is the answer for question 3.6.2. And the final one, write down the valence equation or chemical equation for reaction 2. Reaction 2 is in words. Aluminium carbonate is giving you aluminium oxide plus carbon dioxide. It's very simple because you already have this one here. So you have that aluminium carbonate, which is the one here in 3.6.1, aluminium carbonate Al2 bracket CO3 bracket 3 is going to decompose in 2. So going to decompose into aluminium oxide, which is here, is Al. Hey, that's not an A. Al2O3, that is the aluminium oxide, and is going to decompose in carbon dioxide, but everyone knows the carbon dioxide is CO2. Guys, they don't speak about the state, so let's not add state. If they don't give you the state, you don't write it down. So this is the one, but now we have to make sure the equation is balanced. So let's balance it real fast. Aluminium, we have 2, and we have 2 in the reactants and 2 in the product. Carbon, now carbon we have 3 here because it's carbon at the side of the bracket, but this 3 is for everything that is inside the bracket. So we have 3 carbons in the reactant, but we have only 1 carbon in the product. So let's go to write here A3, and that 3, remember, is for everything, guys. Now oxygen in the reactant we have 3 times 3 is 9. You multiply here this 3 with the 3 of oxygen, is 9 oxygen. And here on the product we have 3 oxygens on this side, we have 3 oxygen, and here we have 3 times 2 is 6. So it's also 9, guys. That is the balance equation there. That is the balance equation, and this is the end of this question 3. Thank you for watching. If you think it helped, thumb up, subscribe for the channel. I'll see you next time. Mr. G here.